Welcome everyone. Today we are continuing Chapter 8. This is Chapter 8.3. We're defining and using zero and negative exponents. So, we have a list of numbers here. We are going to take that list of number and we are going to do the math. Now, we have done everything with positive numbers. We haven't done anything with zero or negatives yet. So we know that 4 to the power of 1, well, that's just 1 4, and that's just 4. So what we're going to do is we're going to start by going up the list. So if we went to 4 to the second power, that would be 4 times 4, which is 16. So what I did was I just multiplied by 4. So if we're going up the list, we're multiplying by 4. The next one then, if we do 16 times 4, we're going to get 64. That's 4 times 4 times 4. And then 64 times 4, that's 4 times 4 times 4 times 4. That's going to give us a positive 256. Now, if we are going down, when we were going up, first of all, we were multiplying by 4. So we were going up and multiplying by 4. If we were going down the list, if we went from, let's say, 16 to 4, we were dividing by 4. So, what we are going to do then, if we're going down the list, we're going to be dividing by 4. So if I take 4 divided by 4, that's going to give us 1. Anytime you have a number to the 0 power, it's going to equal 1. If you put that in your calculator, you'll always get a 1. Now, when we are dealing with negative exponents, we're still going to be dividing by 4. Basically, what we're taking is the reciprocal of 4 to the first power. So if I divide 1 by 4, I get 1 over 4, or 1/4. Now, if I take this one, this is saying I have 2 4s, and I'm going to do the reciprocal of that. So the reciprocal of 16 is actually 1 over 16. So my next number is 1 over 16. Last one then, I take that 4 to the third and I find the reciprocal of that. So 64 over 1, the reciprocal is 1 over 64. So, leave these in fraction form. Do not put them in decimals, so just leave it as 1 over 4, 1 over 16, or 1 over 64. If we go on to this, the first one is just saying that anything to the 0 power is 1. So our example, 5 to the 0 power, that equals 1. If I had 6 to the 0 power, that would equal 1. If I had anything else to the 0 power, that equals 1. If you see a to the negative exponent, or any number to a negative exponent, we're looking to see the reciprocal. So 2 to the negative 1, well, that's just the reciprocal of 2 over 1, which equals 1 over 2. Again, here the reciprocal of 2 would be 1 over 2 to the negative 1. So this could be confusing. We're going to do a lot of practice with these. If the first one we see, so we have 3 to the negative 2. So what we would do is we're going to make this into a fraction. I'm going to take 3 to the negative 2 and I'm going to move it down and make it positive. Now I like to say we're going to move and make positive. So I would move this down. So our reciprocal would be 1 over 3 squared. Now this says evaluate. So we're going to do a little bit more like the simplify. But we're going to make it a little bit more simplified. So I can do 3 squared. So that's actually just 1 over 3 times 3, which is 9. Here we have negative 7 to the 0 power. Anything to the 0 power is just 1. Now here on this problem, if you remember from a couple days ago, if we had a number outside of our parentheses, so if we had like x, y to the power of 2, then that would mean we just have x over y times x over y, which is going to give us x squared over y squared. So we're going to do the same thing here, but this time we are going to have a negative exponent. So I'm just going to erase this here for now. So this here, then, I would have the reciprocal of 1 over 5. So I'm going to give these two the negative 2. So I'd have 1 to the negative 2 over 5 to the negative 2. Now I have a negative, so I'm going to put this on the bottom. I'm going to do the reciprocal. And this one is also negative, so I'm going to take that and put it to the top. So what we're going to have then is 5 squared over 1 squared. Now 5 squared is 5 times 5, which is 25. And 1 times 1, which is just 1. So our answer would then be 25. Here we have 0 to the negative 5th. So what that is saying is that we would have a reciprocal, so it would be 1 over, then we would move this down to the bottom. 0 to the 5th. Well, we can't do anything divided by 0, so this answer would be undefined. Alright, here we have 6 to the negative 4 power times 6 to the 4th power. So what I see is that we have a negative. So I'm going to take this and put a 1 underneath that. I'm going to move this and make it positive. So then what I'll have is 1 over 6 to the 4th power times 6 to the 4th power over 1. Which 6 to the 4th times 1 is just 6 to the 4th, which that means we have 1, 2, 3, 4 sixes. Here we would have same thing, 6, 6, 6, and 6. 4 sixes on the bottom. Those would all cancel, which leaves us with 6 divided by 6, or 6 divided by 6, which is just 1. Here we have 2, so what we have is a negative 2 to the 4th power, or 4 to the negative 2 power. So what we're going to do is we have 2 of those. So we would have 4 to the negative 2 times 4 to the negative 2, and that's all over 1. Now these are both negative, so what I'm going to do is I'm going to take these both and move them down to find the reciprocal. I'm going to move and make positive, so now what we'd have is on the top 1 over 4 squared times 4 squared. This is saying that we have 1, 2, 3, 4 fours. So our answer would just be 1 over 4 to the 4th power. Here we have 3 to the negative 4, that's on the bottom. So if we see a negative exponent, what we can do is move it and make it positive. So we're going to move it up, we're going to find the reciprocal. So what this is saying then is 3 to the positive 4 power over 1, which is just saying 3 to the positive 4 power. Here we have 5 to the negative 1 over 5 to the second. So we're going to take this, because we see a negative, move it to the bottom, find the reciprocal. So move and make positive. So what we're going to have then is 1 on the top, and 5 to the positive 1, and 5 to the positive 2. Now we've got to see how many 5s we have down here. Well, we have 1 5 for the first part, and 2 5s for the second part. So we have 3 5s. So we would have 1 over 5 to the third. Or if we wanted to do that actual problem, 1 times 5, or 1 over 5 times 5 would give us 1 over 125. Alright, so these problems, there can be a lot, but we just need to work with what we know. So what this is saying is that we have 3 of these in the parentheses. So what I'm going to do is I'm going to write these out 3 times. So 2xy to the negative 5 times 2xy to the negative 5 times 2xy to the negative 5. So that's all over 1. So what we're going to do is we're going to find our negative exponents here. What we have is we have 2 to the 1, x to the 1, and then y to the negative 5. So I'm going to move that down here. Same thing here, y to the negative 5, move that down there. And y to the negative 5, and move that down there. So what we have left on the top is 2x times 2x times 2x all over y to the 5th, y to the 5th, and y to the 5th. So what this is saying is that we have 2 times 2 times 2, well that's 8. We have x times x times x, so that's 3 x's, so x to the third, over, we have y to the 5th, y to the 5th, y to the 5th. This is saying we have 5 y's in each of these, so it would be y to the 15th power. Alright, next one. I see a negative exponent, 2x to the negative 2, so I'm going to take that and I'm going to move that down here. So then what we're going to be left with is y to the 5th over negative 4x squared, y squared, and 2x squared. So then what we have, I'm just going to write this all out. On the top we have 5 y's. So we have y, 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 and y. Those are all being multiplied. On the bottom we have a negative 4, then 2 x's, then 2 y's, and we have a 2x and a 2x. Because this is saying that this right here is saying that we have two x's. So what we can do is simplify this now. I see 2y's on the bottom and 5y's on the top. So what I can do is cancel out some of the y's. So on the top we have y to the third power now. Then if we just multiply what we have on the bottom, negative 4 times 2 gives me a negative 8. Negative 8 times 2 gives me a negative 16. And we have 1, 2, 3, 4 x's on the bottom. So we have y to the third over negative 16x to the fourth. If we go on to our next slide, here again we have something with a negative exponent, but the only thing with a negative exponent is that y. So I'm going to take the y and I'm going to bring that down. So we are going to have 3x on top over 9x cubed y, and then y to the positive 3. So if we write these all out, then we're going to have 3 and x on the top. Then we would have 1, 9, 1, 2, 3 x's, a y, and 1, 2, 3 more x's, or y's, I mean. Now what I see is an x on the top and an x on the bottom. So I can take those x's and cancel them. 3 and 9, I see that I can divide both of these by 3. So I would have 1 over 3. Now we have 2 x's left, so x squared on the bottom, and 1, 2, 3, 4 y's, so y to the fourth. Here I see that we have 3x to the negative 3. So what we're going to do is we're going to take this whole thing down and bring that down to the bottom. So what we would have then is y to the fourth on top. Now be careful, here on the bottom we also have a y to the negative 6. So we're going to take that y to the negative 6 and bring that up. So y to the fourth and y to the sixth. On the bottom then we're going to have negative x squared and 3x to the third now. So if we were to write this all out then, on the top we would have 1, 2, 3, 4 y's times 1, 2, 3, 4, 5, 6 y's. On the bottom, we're going to have a negative 1 and 2 x's, then 3 x's, so I see nothing that I can cancel because all my y's are on the top and all my x's are on the bottom. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 y's. So we would have y to the 10th on the top. Now I can do some multiplying here. Negative 1 times 3 is negative 3, times 3 is negative 9, times 3 is negative 27. And 1, 2, 3, 4, 5 x's. Next one, what I see is we have a negative 3. So I'm going to take this whole thing and I'm going to make that a fraction and move it to the bottom. So we would have 1 over 6x to the negative 2 y to the third, that all 3 times. So then we would write that all out 3 times. So we would have 1, let's write the bottom first. We would have 6x to the negative 2 y cubed times 6x to the negative 2 y cubed times 6x to the negative 2 y cubed. That's all going to be over 1. Now I see a negative exponent on our x, so I'm going to take that and move it up, take this one and move it up, and take this one and move it up. So then what we would have would be x squared times x squared times x squared over 6 times y cubed, 6 times y cubed, and 6 times y cubed. So on our top we have 6 x's, so x to the 6th over 1, 2, 3 6's, so 6 cubed, and 1, 2, 3, 4, 5, 6, 7, 8, 9 y's, so y to the 9th. Now you could do 6 to the third if you wanted to. I'm just going to leave it simplified like that. Here I see that I have a negative 2, so I'm going to move that down. This one I have a negative 4, so I'm going to move that up. So what we have is s to the positive 4 over r to the positive 2. Here I'm going to take x to the negative 2 and I'm going to move that up, and y to the negative 6 and move that up. So what we would have then would be 1 on top with our x squared now, and y to the 6th over 8. We still have that 8 down on the bottom. Alright, last problem says a sheet of 67-pound paper has a thickness of 100 to the negative 1 inch. Write and evaluate an expression for the total thickness of 5 sheets of 67-pound paper. So we're going to have 5 of these sheets, and we're multiplying, so we can see 5 times 100 to the negative 1. So what I can do then is make this a fraction and move the 100 to the negative 1 down on the bottom. So actually we would have 5 to the over 100 to the 1, which is actually just 100. Now we can divide both of these by 5. And we would get 1 over 20. Here, same thing, but this time we're looking for 2 to the 3rd sheets of paper. So it would be 2 to the 3rd times 100 to the negative 1. We're going to take that 100 to the negative 1 and move it down. So we would have 2 to the 3rd over 100. Now 2 to the 3rd would be 2 times 2, which is 4, times 2 again, which is 8. So we would have 8 over 100. Both of those we could put in, or take 2 out of. Or we could actually take 4 out of them. 8 divided by 4, that gives us 2. 100 divided by 4, that gives us 25.